Hi guys, so today we're going to be learning about rhombi and squares. And before we get started with our first example problem, let's look at the definition of a rhombus and some of its properties. Okay. So the most famous rhombus that you probably know is the shape known as a square. And a square is a special type of parallelogram called a rhombus. A rhombus is a quadrilateral, so a four-sided shape, where all four sides are congruent. Because the rhombus and the square is part of the parallelogram family, all of the properties of the parallelogram are applied to the rhombi. Okay. Here are some other characteristics about a rhombus. Okay. The diagonals of a rhombus are perpendicular. So here you see the diagonal AC and BD, and you can see that they form a 90-degree angle. Okay. And the converse of it is also true. If the diagonals of a parallelogram are perpendicular, then that parallelogram is a rhombus. And then the other thing we know is that each diagonal of the rhombus bisects the pair of opposite angles. And so you'll see this angle A here is now bisected into this part and this part being equal. Angle C is bisected, this part and this part is equal, so is angle B and angle D. Okay. So with our first example, we're just going to look at it through the book. Okay, that way it's a little bit easier to follow. Okay, so let me adjust. Okay, so basically we're proving the fact that the diagonals of a rhombus are perpendicular. Okay, so here we're given this quadrilateral PQRS is a rhombus, and we want to prove the diagonals are perpendicular. So we want to prove that that theorem is true. Okay. So this is a paragraph proof. By the definition of a rhombus, all of the sides are equal, right? So PQ is congruent to QR, which is congruent to RS, which is congruent to PS. Right? Definition of rhombus, all four sides are congruent. Okay. Then, still have the picture. Okay. Then, what we know is that a rhombus is a parallelogram, and so the diagonals of the parallelogram bisect each other. So as a result, QS here bisects PR. And as a result, PT here is congruent to RT. And then we know QT is congruent to QT because of the reflexive property. As a result, angle PQT, this angle here, is congruent to this angle here, RQT, right? Due to side-side-side congruence postulate, right? Because if a rhombus, all sides are congruent, this side is congruent to this side. Because its diagonals are bisected, this side is equal to congruent to this side, and then reflexive property, this side is congruent to this side. Okay. As a result, with these two congruent triangles, angle QTP, which is here, is congruent to angle QTR here due to CPCTC. Right? Congruent parts of congruent triangles are congruent. Okay. So then, if these two are congruent, we also know that they form a linear pair. And in order for two angles to be congruent and be a linear pair, those two angles have to be right angles. Right? If they're equal, right, and to add it to 180, that means this has to be 90, this has to be 90 degrees, right angles. Okay? And since that is a right angle, then we know that PR is perpendicular to SQ because perpendicular lines form right angles. Okay. So now why don't you do CYP1, and then once you're done, come check your answer. Okay, you should have gotten something along these lines. Okay, so make sure you include your reasoning, since oftentimes you guys kind of just state something without giving a reasoning, right? So again, everything has to be backed up with a reason, okay? So I started here with, since it is given that triangle JKL is isosceles, segment KL is congruent to segment JK by definition. So here, I'm just going to mark it as we go so that way you can see what I'm talking about. All right, so because this is an isosceles triangle, this and this is congruent, okay, based off of the definition of isosceles triangle. Then, it is given, so that's my reasoning, that JKLM is a parallelogram. So JK is congruent to LM because opposite sides of a parallelogram are congruent. Okay? All right, so we know that it's a parallelogram, opposite sides of a parallelogram are congruent. So JK here, that's here, is congruent to LN. Okay? All right, so now we have JK congruent to this and JK congruent to this. Okay? Then, as a result, by the transitive property, then we can connect KL with LN. Right, so then now this is congruent to this. So right now, everything is congruent to each other. We just haven't talked about this one yet. Okay. Then the next part, it just says by the symmetric property, JK is congruent to KL. So it just switches this. That's the symmetric property. Okay. And as a result, since JKLM is a parallelogram, again, opposite sides are congruent. So KL is congruent to JM. So this is our first introduction of this other one. And so then, by the transitive property, JK is congruent to JM. So this is congruent to this, right? And we know this is congruent to this is congruent to this, they're congruent to each other. So by definition, JKLM is a rhombus because all of these four sides are congruent to each other. There we go. Okay. So now moving to example 2. So here we're going to use rhombus QRST, so that's what we're given, as well as this given information to find the value of each variable. Okay. So here it says find y if measure of angle 3, so that's here, is y squared minus 31. So here we see that angle 3 is formed by the two diagonals. And what we know about the diagonals of a rhombus is that they're perpendicular. So as a result, the measure of angle 3 is 90 degrees. So y squared minus 31 equals 90. Okay, then I'm going to solve this quadratic by taking square roots of both sides once it's isolated. So I'm going to add 31 to both sides. So that gives me y squared equals 121. And then I'm going to get rid of the square. I'm going to get rid of the square by square rooting both sides. And when I do that to solve for a variable, I have both the positive and the negative root. Okay. And then square root of 121 is 11. So I have positive 11 and negative 11. Okay. So oftentimes we need to check if it results in something negative, right? So even with the negative 11, because it's squared, it becomes a positive 121 minus 31 is 90. So in this case, there is no extraneous solution. I want both the positive 11 and the negative 11 work as solutions because they're both true. Okay, then with 2b here, it wants us to find the measure of angle TQS. So TQS is this part here. And what we know is that RST, this whole thing, is 56 degrees. So what we know is that for a rhombus, the diagonals bisect opposite angles, right? So parallelogram opposite angles are congruent, and then for a rhombus, the perpendicular bisects it. So what that means is that the measure of angle TQS is going to be half of that 56. Then half of 56 is 28, so the measure of angle TQS is 28 degrees. There you go. Okay, so why don't you try CYP2, and then once you're done, come check your answer. Okay, you should have gotten 114 degrees. Okay, so here, we were asked for angle QTS, so we don't know what this is. Okay. However, we know that angle 2 here is 57 degrees. Okay. So again, diagonals for a rhombus bisect each other, so that means this would be 57 degrees as well, which means this would total to be 114. And since opposite angles of a parallelogram are congruent, that means this whole thing has to be 114 as well. Okay, okay. So now let's do example 3. Okay, so example 3 here asks us to determine whether a parallelogram ABCD is a rhombus, a rectangle, or a square. Okay, but before we get to that, let's look at the square. Okay, so a square. A square is a quadrilateral that is both a rhombus and a rectangle, okay? And it's also a parallelogram. So as a result, all of the properties of a parallelogram, rectangle, and rhombus apply to a square. Okay? So a square is part of all of those families, right? It's a parallelogram because opposite sides are congruent. It's a rhombus because all four sides are congruent. And it's a rectangle because its interior angles are each 90 degrees. There are four right angles. Okay, so with example 3 here, we're determining which families it's a part of. Okay? And to list all that apply. So first, what I'm going to do is I'm going to look at several properties of them. So what I'm going to do is I'm going to use the rectangle one. I'm going to use the fact that the diagonals are congruent. Okay. For a rhombus, I'm going to use that the diagonals are perpendicular. Okay. And then a square is both a rectangle and a rhombus. So if it meets both of these, then it's going to be a square. Okay? Okay, so then let me draw my diagonals. I don't have to, but it just helps me to see it a little bit clearer. BD is one of them, and then AC is the other. Okay, so I'm going to start by looking if it's a rectangle by seeing if the diagonals are congruent. So BD, so using the distance formula, square root of the x subtracting, so negative 3 minus 3 squared, so negative 3 minus 3 squared, plus 1 minus negative 1 squared. 1 minus negative 1. Okay, now I'm going to simplify. Negative 3 minus 3 is negative 6. 1 minus negative 1, minus a negative means plus, so 1 plus 1 is 2. Okay. Negative 6 squared is 36, 2 squared is 4, 36 plus 4 is 40, and then when I square root 40, that simplifies to 2 squared of 10. Okay, that's the length of BD, that's how long it is. Okay, then let's do AC, okay. See how long that is using distance formula. Okay. So then that's 1 minus negative 1 squared, okay. X minus x, 1 minus negative 1 squared, plus 3 minus negative 3 squared, 3 minus negative 3 squared. And I'm going to simplify. 1 minus a negative, again, is plus, so this is 2 squared. 3 minus a negative, again, is plus, so that's 6 squared. 2 squared plus 6 squared is, 2 squared is 4, 6 squared is 36. 4 plus 36 is 40, which simplifies to 2 squared of 10. So they are the same. So these diagonals are congruent. And so that's why it's a rectangle. Okay. The other way you could have done it is you could have also done it where you proved 4 right angles as well. Okay. And then in that case, you would find the slope of each side and prove that. So that's another way you could do the same thing to show that this is a rectangle. Okay, so then for rhombus, I'm going to use the property that the diagonals are congruent. Okay, so I'm going to find the slope of BD. Okay, so BD here, I'm going down to 1, 2, and going across 6. So down 2 is negative 2, right 6 is 6, positive 6. This simplifies to negative 1/3. Okay. Then I'm going to do the slope of AC. Okay. So A to C, I'm going up 6 and right 2. So up 6 is positive 6, right 2 is positive 2, 6 over 2 is 3. So these are opposite or negative reciprocals. So as a result, BD is is perpendicular to AC. And so since the diagonals are perpendicular, this is a rhombus. Okay. If you didn't want to do it this way, the other way you could have done it is you can show that it has 4 congruent sides. So if you found the length of each of the sides, you could prove that they're congruent. That is also a rhombus. So you would find the distance, right? So alternative ways to prove that it's a rectangle or prove that it's a rhombus. Okay, and then because it's a rectangle and a rhombus, it is also a square. Very good. Okay. So why don't you try CYP3, and then once you're done, come check your answer. Okay, so you should have gotten that it's a rectangle, a rhombus, and a square. The reason why it's a rectangle is because the diagonals are congruent. The other way you could have done that is by finding the slope of each one and then showing that this is perpendicular to this is perpendicular to this is perpendicular to this is perpendicular to this. So that's another way you can show that it's a rectangle. Okay, so either way works. Okay. Then I showed that it's a rhombus by showing that the diagonals MK and JL are perpendicular because their slopes are negative or opposite reciprocals. Okay, so that's how I got that. Okay. The other way you could have done it is that you could have found the distance of each of the sides using the distance formula and then seen that if they're congruent or not. Okay. And then lastly, it's a square because it is both a rectangle and a rhombus. Okay, so here's the next question here. So example 4, the infield of a baseball diamond is a square as shown at the right. Okay. We want to know, is this pitcher's mound located in the center of the infield, and to explain why. Okay. So what we know is that because it's a square, okay, that the diagonals are bisected, right? That's part of the properties of a square because it's a property of a rectangle. Okay. So here we want to see, is half of this equal to this? Okay. Because the diagonals are bisected and congruent. Okay. So here, we're going to take the 127 feet and 3 3/8 inches, and we're going to divide it by 2. Okay? So that 127 feet divided by 2 is 63 with 1 foot left over, so that we're going to give that 12 feet is, 1 feet is 12 inches, so that 15 inches, divide that by 2, that's 7 inches. Okay, with 1 left over, and then combine it with this 11/8 divided by 2 is 11/16. So here, this is 63 feet, 7, 11, 16 inches. That's how long this to this is. Okay, so that's 63 feet, blah, 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 blah. Okay, however, from here to here, this is 60 feet and 6 inches. So because they're not congruent, that means this is not in the center. Okay, so then why don't you try CYP4, and then once you're done, come check your answer. Okay, so for this question, we're just determining if these tiles are rhombi. And so what we know about rhombi, or a rhombus, is that the diagonals are perpendicular and they bisect each other. So to determine if the tiles are rhombi, what we can do is we can measure the diagonals to see if they bisect each other. And then we can also measure the angle of the diagonals to see if they are right angles. There you go. Okay. So now we're going to end with constructing some rhombi. So constructing a rhombus is super easy. Right? It's based off of the idea that a rhombus, all the sides are congruent. Okay? So what we're going to do is first, you're going to draw a length of however long you want your rhombus side to be. Okay? So I'm going to do this. I'm going to draw it. Okay, and I just want it to be this long. Okay? A and B. Okay. Then I just need to find how far away the different points are from A and B. So I'm going to use my compass to measure how long A and B is. And because a rhombus is, all 4 sides are congruent, that's why I'm going to keep this measurement. Okay? So I'm going to make a mark. Okay? And what this is all of these points are the same distance away from A. They are this length away from A, all of these points. Okay? I'm going to do the same thing for B. From B, leaving my compass the same, that mark. Okay? And what this means is all of these points are the same distance from B. Okay. Then, the next point, I'm going to determine where I want the next point. So it has to be along here, or if I want to do this point next, it has to be along here. So I'm just going to say I want to do this point, and I want it here. Okay? Right, so right now, so far so good, because this point is this length away. Right? Again. Okay, so while we have this, where it's all that length away from B, we need to make sure that wherever this point is, that it's also the same distance away from here, right? Because rhombus is all 4 congruent sides. So this is congruent right now, all of these, and this is congruent from B, But right now, we need to figure out where this point is congruent away, or same distance away from this one. Take that measurement then from that third point, make a mark. And so what this means is like these points are all the same distance away from B, and everything on this line is the same distance away from this one. So in order to be the same distance from this and this, that is this point right here. Okay. And so then all I have to do is connect them. And then there is my rhombus. There you go. C, and this is D. Nice and easy. Okay, so I'm just going to quickly do another one. So again, whatever length you want for your rhombus. Could be super small, could be super long. Okay. Let's do E and F. Okay, so repeat it again. I'm going to measure how far E and F is, right? Because all of my sides have to be this far away. Right. Then I'm going to make a mark. Okay, so all these points are that distance away from E. All of these points are that distance away from F. Okay? If I want it to be more square-ish, I'll probably do it directly across, but it's still not perfect. Okay? Now this point I'm going to choose for my next one. And then I need to make sure that my last point is that same distance away from this one. So then from there, make my marking. This will be G and H. Okay. Although this one looks more squarish because I try to do it perpendicularly. Okay, it's still not perfect because I didn't actually make sure that it was a perpendicular line. Okay, so if I did want to make it a square, what I would do is I would combine the steps for this rhombus with the steps of a rectangle. Right? And then that I could get an actual square. Okay, so that's it for today. Have a great rest of the day. Bye, guys.